everyone. I'm Won Lee. Okay, I'm lecturing intermediate statistics. Today, I'm going to talk about characteristics of data. Characteristics. First one is representative value, and the second one is how to dispose. Okay, degree of dispersion is the second one. I mentioned sample yesterday. We some observed values, set of observed values. We call it sample. Population is background of sample. Okay, population. We do not know the values of population, so we say theoretical group of data is population. Okay, let's go to characteristics of data today. First one is what? Mean, average. Second one is median. I just mentioned a little about median last time. Okay, repeat it. Median is the value that is located in the middle of data. When the data is arranged in order of size, size means magnitude, okay? Advantage, it is not affected by outliers. Outliers means extreme values. So I get some simple example here, but however, okay, deriving the median theoretically is difficult. That's why we do not mention median for the highly skewed data. Highly skewed data is something like this. Typically, it is income data, okay? High income, low income, some middle income. So this is what? Median value here, median here, then 50% of income is lower than median. The last 50% of incomes are greater than median. 50%, 50%, right? So in this case, where is average, mean? Average or mean is will be located around here, mean. You understand that? Okay, there's some applied concept. Trimmed mean. Trimmed mean is average of remaining values after excluding small or large values, small one value or small values. How many smalls? How many large exclude? Okay, when they are 9 data points. Okay, suppose there are 9 data points. 25% trimmed mean means excluding two smallest and two largest values from the 9 data points. Why two? 9 times total 9 times 0.25 is 2.25. So we use only 2. You use 3, it's gonna make some trouble. Okay? If you exclude the 3 smallest, 3 largest, then remaining is 3. So you have calculate mean with only remaining 3 values. It is not reasonable. So think about that kind of thing. So the average of remaining 5 values. It is used as an proper representative value for scoring, where personal subjectivity is involved. Example, gymnastics, diving, figure skating, right? So you can see when you watch TV on gymnastic, diving, figure skating, you can see this trimmed mean. Second one is percentile. 95% percentile, we denoted P 95. Value located at the 95th percentile when arranged the data in order of size, magnitude. In other words, top 5%. P30, value located at the 30th percentile when arranged in order of size, magnitude. Okay, what is median? Median. 50% percentile is median, right? Yeah, it is a simple terminologies here, but sometimes you may use this kind of simple concept. Okay, let's see. Degree of dispersion. There are two uh, terminology: quartile deviation and variance. Variance, of course, is very, very important in statistics. There is another thing, but it is not significant. The range. Range is, as the name suggests, value obtained by subtracting median from the maximum. So in that range, data are spread, you say. So it is not meaningful terminology. Quartile deviation indicates how much the middle 50% of data covers. Okay, to calculate quartile deviation, we first define Q1, Q2, Q3. What is Q1, Q2, Q3? They are data. Strangely, data is spread in center, from center here. Anyway, here is Q1, 25% percentile. Here is Q3, 75% percentile, Q3. Then Q3 minus Q1 is, we say, interquartile range. Okay, so quartile deviation is QD, Q3 minus Q1 divided by 2. Okay, they are 50% of data in this range. 25 here, 25 here, right? Quartile deviation is the value obtained by dividing the range of middle 50s of data by 2. It is mainly used to compare which groups data is centered among several groups. There are several groups. So which group is centered, centered, okay? Standard deviation or variance. Standard deviation is important indicator that shows how closely, how narrowly, or widely the data values are spread around the mean. Okay? First, variance is calculated, and then we may calculate standard deviation. For example, x1, x2, xn, small letters, observed values, real values, okay? xi minus x bar, we call it deviation. What is deviation? Okay, there are many data x's here, like this. Then where is x bar? X bar is around here. Here is x bar. x1 minus x bar, x2 minus x bar, x3 minus x bar, xn minus x bar. We call them deviations. Okay, there are n many deviations. What is variance? Variance is average mean of squared deviations. Squared deviations, okay, n many squared deviations, and average them. That is what? Variance. But there are n here squared deviation, but divided by n minus 1. What is n minus 1? We call it degrees of freedom. Okay? Instead of n, we have to use n minus 1 here because of degrees of freedom. And I will explain degrees of freedom later. But unit of variance is square of measurement unit of data. Okay, data unit is dollar. Then deviation has dollar unit. But squared deviation, these have dollar square. So what? Variance will have dollar square unit. What is a dollar square unit? We do not understand. We do not imagine that kind of a scale. That's why how to do it? Square root variance. Square root variance, then the unit will be squared. So the result has what? Dollar unit. Okay? Same measurement unit of data. That's why we call it standard deviation. That is standard deviation, S equal to square root summation xi minus x bar square n minus 1. Okay, got it? So if you get variance 16, then standard deviation is 4. If you have 3 standard deviation, then the variance will be 9, even though those two have different unit. Okay? Okay, I'm gonna stop today because a little more, some complicated thing, so I'm gonna explain it later. Okay, thank you. Bye.